Cyclic aliphatics. Let's look at the characteristics of cycloalkanes on this flowchart. The cycloalkanes that are saturated follow this formula. Cyclic aliphatics include both cycloalkanes, which are saturated, and unsaturated rings, but not the benzene ring. They're part of the aliphatic group, and the ring structure is what the prefix cyclo signifies. I'll focus mostly on the cycloalkanes and look at some cycloalkenes at the end. The first one is cyclopropane C3H6. It consists of 3 carbon atoms arranged in a ring. This is the structural formula. The next one, cyclobutane, has 4 carbon atoms connected as a square. Cyclopentane is a pentagon. And cyclohexane, with 6 atoms, is in the form of a hexagon. These are the condensed formulas. The simplest and most common way of representing them is by line diagrams like this: triangle, square, pentagon, hexagon. The last two are by far the most commonly occurring. One note: don't confuse this saturated hexagon with benzene, which has double bonds. The boiling point shows the first two are gases at room temperature. Cyclopentane and cyclohexane are liquids. Let's now look at naming with substituents. This cyclohexane has a methyl substituent, so methyl cyclohexane is the name. There's no need to locate it on the ring, as every point here is equivalent. The next one has ethyl attached to it. Note that ethyl can also be written in this condensed form. This is ethyl cyclohexane. Here is the propyl group, so propyl cyclohexane. In this structure, we have a 3-carbon chain again, but shown as a wedge shape. Propyl is still the base name, but the connection to the ring is now from the middle carbon, which I've labeled 1. The name is isopropyl cyclohexane. The term iso refers to a 3-carbon chain whose attachment is from the middle carbon. It could also be written like this. The fact that there are 3 carbons makes it isopropyl. This structure shows the iso configuration, but with 4 carbons, so it is called isobutyl. A 5th carbon would make it isopentyl, and so on. But UPAC recognizes only isopropyl and isobutyl as accepted common names. I'll remove these now and return to our molecule. This straight line structure will make it easier to understand another name for this group. We label the carbon that is attached to the ring as carbon 1. The 2 carbons in this box are an ethyl group, so we can see that the CH3 is a methyl group attached to this ethyl group. The other 2 carbons could have been chosen for ethyl as well. Either way, both will work. This leads to the name methyl ethyl as an alternative to isopropyl. We put this group in brackets and add the ring. The 1 indicates the carbon that methyl is attached to on ethyl. How would you name this one? Think of the 3 carbons starting at 1 as a propyl group with methyl attached to it to make a methylpropyl group this time. The name is 1-methylpropyl cyclohexane. This diagram may look different, but it's actually the same molecule. The number 1 shows the propyl group with the methyl attachment. How would you name this one? The numbering shows a methyl attached to carbon 2 of the propyl group, so we get 2-methylpropyl cyclohexane. Let's now look at 2 substituents on the ring. This will be a dimethyl cyclopentane. We want to have the lowest numbers, so we number clockwise and get 1,3-dimethyl-cyclopentane. How about this one? It looks very much like the previous one, but the same numbering order will give an incorrect name. So we number counterclockwise. This time we get 1,3-dimethylcyclopentane, the same name, because it's the same molecule. Name this one. Since bromine comes before methyl, we give bromine number 1. And that gives us 1-bromo-3-methyl-cyclopentane. We always select the direction that gives the lowest numbers. Next one. By the way, this diagram shows CH3 written, it seems, backwards, but it is most often used now to show clearly the bond going to carbon. In the above drawing, the argument goes, people may think the bond is to hydrogen, but this mistake is easily and quickly overcome, so both notations are understood and acceptable. Ethyl comes before methyl, so start here, and the name is 1-ethyl-3-methyl-cyclopentane. This one has hydroxy and ethyl. Now, although ethyl is before hydroxy alphabetically, hydroxy is a functional group called an alcohol and takes precedence over ethyl. The name is 1-hydroxy-3-ethyl-cyclohexane. And this is correct if you're not aware of functional groups. At this point, I'm assuming you aren't. So I'm only bringing up this example to show that the naming changes if there are functional groups. Name this one. You recognize the isopropyl group here. Now, iso is not a prefix that indicates a number like di, tri, tetra. It's called isopropyl and is taken into account for alphabetizing. Since isopropyl comes before methyl, we number it first and get 1-isopropyl-4-methyl-cyclohexane. If you want to use the methyl-ethyl naming, and if we keep the same numbering on the ring, we get this name. But if we change it to make methyl at carbon 1, we get this one. Having 1-methyl is preferred over 4-methyl. So this name is correct. We'll look at some tri-substitutions now and then go no further. This one is a trimethyl-cyclopentane, but does it matter how we number it? Let's start this way, and we get 1,3,4-trimethylcyclopentane. Now let's start down here and go in the reverse direction. This gives us 1,2,4-trimethylcyclopentane. The correct one has the smallest sum of numbers, so the bottom one, with a total of 7, is correct, while the one at the top with a total of 8 would be incorrect. Next one. Since ethyl comes before methyl, let's start numbering at ethyl. This gives us 1-ethyl-3,4-dimethylcyclohexane. Now let's start with the top methyl. This gives 4-ethyl-1,2-dimethylcyclohexane. Which one is correct? The bottom one is correct. Ethyl is correctly first in both cases, but the sum of 7 is lower than 8. Try this one. Bromine is first alphabetically, so we'll give it number 1. Which way do we go next? Ethyl comes before methyl, so we'll number in this direction. And now we have our name, 1-bromo-2-ethyl-6-methylcyclohexane. This one is here to point out that sometimes the ring acts as a substituent rather than the main component. This occurs when the chain has more carbon atoms than the ring. The ring has 5 carbons compared to the 6 in the hexane chain. As a substituent, the ending YL is used, so the group is cyclohexyl, and the name is 3-cyclohexyl hexane. This last slide will introduce some cycloalkenes. This one is simply cyclohexene. The position of the double bond doesn't matter here. But once a substituent is added, the double bond takes precedence over the alkyl groups and halogens I've been using. Number the double bond so that methyl has the lowest number. This gives 3-methyl-1-cyclohexane. If we numbered in the other direction, methyl would be on carbon 6, which would give a wrong name. Name this one. In this case, a substitution on the double bond makes that carbon number 1. We locate chlorine on carbon 1, as well as the position of the double bond, giving 1-chloro-1-cyclohexene. Name these two and come back to check your answers. Here's the first one. In the last one, note that once carbon 1 of the double bond is identified, the next number 2 must contain the double bond. That is why the counterclockwise direction was necessary. Here's the name. And this ends the introduction to nomenclature of cyclic aliphatics.